Every enterprise investing in AI agents right now is hitting the same wall. The models are incredible. They can reason, plan, hold complex conversations, but in production, every session starts from zero. A customer who's bought from you 6 times gets asked the same question. An agent that solved a similar problem yesterday is rerunning the entire reasoning chain from scratch. And when compliance asked why a recommendation was made, nobody can trace the decision. These aren't model problems, these are actually memory problems, and they show up as lower conversion, high compute cost, and regulatory exposure. Now, let me walk you through a demo that shows exactly what changes when you give an agent a knowledge layer. Think of yourself as a retailer for a shoe company, and we're building an agent who would help our customers with the best options. So these are two agents side by side, same model running on Claude Sonnet. Left side has no memory, it has no tools, just vector search lookup. This is how most AI assistants work today. Right side is connected to a Neo4j knowledge graph with short term, long term, and reasoning memory. Our customer here is Alex. Alex has narrow feet, size 9.5, been shopping with us for a year. Let's ask both the same question. Now, on the left side, you see it immediately starts asking questions like what's your size, what's your width, what's your budget. Alex has been a customer for a year and the agent doesn't know a single thing about her. Now, look at the right side. No questions, it went straight to recommendations. It's recommending Alex new Alex 1080V13. It's calling out 24 positive reviews from narrow foot runners. It's quoting them directly. Most comfortable shoe I've ever worn. It connected her past purchases notes to this recommendation. Now, there's long term memory. It's building on her purchase history. The third pick here, the GT 2001, and it found a reviewer who rotates between GT2000 and the Kinvara, a shoe other narrow-footed customers love. That's cross-user graph traversal at work. Now, on the left side, we have finally enough to work with. Let's see what it came back with. A6 Gel Nimbus series, not a specific model, but the series. Brooks Ghost series, Balance Fresh Foam series again, no prices, no stock availability, no review data. And then it says, I definitely recommend trying them on in store if possible. The agent is literally telling Alex it can't actually help her. Now let's switch to Aura Console. This is what the right side agent is seeing. Alex's complete profile, all the data around purchases, rejects, and what she viewed. This is called long-term memory. It loaded this in its first tool call. That's why it never had to ask a single question. And this is the recommendation query. One traversal, 5 hops, Alex's purchases, reviews from customers, the shoes they bought. Every quote the agent cited traces back through this graph. That's provenance you can audit. The graph also takes into account the other users like you see Sam Rivera and their purchases to best recommend Alex. Now let's move to the chatbot. Tell me more about the heel fit on the Kinvara 14N. The agent doesn't reintroduce itself or reload the profile. That's short-term memory. It remembers what we just discussed and it's pulling heel-specific review insights from narrow-footed runners, cross-referencing them with Alex's note that she loved the heel lock on Ghost 15. I went with the Kinvara last time. Now I want something with more cushion but the same fit. Now let's watch what happens. Alex is coming back as a returning customer. The agent doesn't start the recommendation process from scratch. It found its own prior decision trace. It recommended 3 shoes last time. Alex chose the Kinvara and the 2 are still untried. Now instead of rerunning the full 5 hop traversal, it's reusing that work. That's reasoning memory. Few token calls, low latency, and fewer tokens. Back to the Aura console. Let's run this query. 3 sessions in the graph, each one connected to its recommendation and to the shoe. The second session learned from the first. The third reused decisions from the second. That's agents getting smarter over time. It did that through memory. As you can see, it's storing past conversation and the time to decision as well. Let's do the audit trail in the chat box now. I just bought the New Balance 1080V13N and the toe box is amazing for my narrow feet. The agent just wrote this purchase back to Alex's profile. Rating, fit, date, her long-term memory just got richer. Next time she comes back, the agent already knows about this shoe and what she thought of the toe box. The profile compounds with every single interaction. Now let's switch back to AuraDB. After running this query, here's the compliance story. Every decision the agent made is in this graph. What tool it called, what query it ran, what reasoning it applied, what memory type it used, all in the decision trace node. When someone asks, why did you recommend the 1080V13 to this customer, you trace it. Customer profile, you can trace similar users, you can see review insights and recommendation. Now let's look at the big picture. You see 8 node types, 15 relationship types. This is one customer. Imagine this across your entire customer base. Every preference, every purchase, every return reason, every review insights, every agent decision, all connected. And every interaction just makes this graph smarter. There are three takeaways from this. The left side agent told Alex to go try shoes in a store. The right side agent gave her three specific recommendations backed by 24 verified review from customers with her exact foot type. The difference here is that the right side had memory. Agents with a knowledge layer don't ask questions they should already know the answers to. They don't repeat work they've already done, and every decision they make can be traced and explained. That's the Neo4j knowledge layer, short term, long term, and reasoning memory all connected in one graph. Thank you for watching.